All right, so of course, we have been having a wonderful time here at the Cloud University, and we are here to address a very common problem that all of us face as we are growing in number of applications and the complexity of the applications as well. And one of the biggest pillars for ensuring that we want to have resilient applications is observability, right? So today we are going to be talking about how we can bridge the OpenTelemetry adoption gap within cloud-native applications. So with me is Shivanshu from SigNoz, and I'm Shivay from Couchbase. Just a quick introduction. So Shivanshu.
Hi everyone, this is Shivanshu. I'm a founding engineer at SigNoz. I'm also a CNCF ambassador and member and contributor to OpenTelemetry.
Yeah, and I'm Shivay. I'm working as a developer experience engineer at Couchbase, which is a NoSQL database, and I'm also a CNCF ambassador like Shivanshu. Now, one of the biggest observability papers was conducted by Dynatrace in the State of Observability 2024, which kind of shows a very big gap that we have in the industry today. Because as we know that bigger and bigger applications are coming up every day, and the complexity of managing thousands of microservices leads to the capabilities of having more faults inside of your systems. So accordingly, 86% of technology leaders say that the stacks that are being currently implemented to understand the monitoring of these applications is becoming very complex, because for every single thing, you might need a separate type of observability tool. And sometimes companies might have 10, 15 different types of observability tools trying to identify and understand different parts of the system. So when it comes to managing all these tools, there are of course, different type of complexities that come up with just managing like 20 different type of tools. So that's the reason why we're going to be talking about OpenTelemetry today, because if you look on the left-hand side of the screen, you'll see a classic example where if you're looking at your MELT framework, which means you're looking at your matrices or metrics, traces, logs, you'll need to use different tools in order to capture the details of all of these tools. But okay, even if you're using different tools, that anyways adds to the complexity. But then you'll have to find out correlations between these different tools, which again adds to further complexity. But this is where OpenTelemetry as a solution can be helpful. And of course, Shivanshu will go deeper into what OpenTelemetry is and with the context of in today's current cloud-native applications. But it's one single tool where under one single process, you can get data of all of these different metrics, logs, and traces, and also identify how they are correlated with each other. So over to you, Shivanshu.
Yeah, so OpenTelemetry was started with merging of OpenCensus and OpenTracing, and then OpenTelemetry got started. So it's currently a second fastest growing project in the CNCF landscape after Kubernetes. There's no vendor locking, so it provides a generic way to instrument all of your application using the semantic conventions, and all the agents and auto-instrumentation agents follow those semantic conventions. So you can just adopt OpenTelemetry and be vendor agnostic. It's becoming the default standard for instrumentation across all the projects, not just CNCF. So if you are in this space of, let's say, LLM monitoring, it's also is compatible with OpenTelemetry. It provides a variety of things. So for example, if you are using any language, be it Golang, Java, or any other language, it provides the native SDK that you can use to enable metrics, logging, tracing in your applications. And also it provides some auto-instrumentation agents for languages like Java and Go, where you can have out-of-the-box instrumentation of your applications. So in a nutshell, this is the ecosystem of OpenTelemetry, where on the left-hand side, you have all the SDKs and OTel API and the auto-instrumentation agent. And on the infra side, so for example, all the CNCF tools natively supports emitting OpenTelemetry-based metrics, traces, and logs. So for example, Kubernetes and L7 proxies like Envoy provides a way for you to configure and collect telemetry right from the Kubernetes and proxies. The OpenTelemetry collector acts as a central ingestion pipeline where you can ingest telemetry from across your applications and infrastructure. You can process them, and then you can send them to any backend which is compatible with OpenTelemetry. So Yuri, who was one of the co-creator of OpenTelemetry, introduced this concept of temple, which are the 6 pillars of observability: traces, events, metrics, profiles, and logs. Also, exceptions is one of the pillar. So let's see how OpenTelemetry helps in standardizing and correlating between different signals. So this is just an example where once you have collected everything from your applications and infrastructure, you can just send it to OpenTelemetry, and you can have a single pane of glass where you can visualize your metrics, your exceptions, logs, and traces in a single pane of glass. And because of the semantic conventions, there is a very good correlation between all these signals. And recently, OpenTelemetry has announced profiling support for OpenTelemetry for your applications. So this is, like if you zoom in into collectors, this is how it looks like. You have receivers where you can configure different receivers for the different purposes. So the native protocol that OpenTelemetry uses is OTLP, but you can configure Jaeger, Prometheus, Zipkin, or if you are using a cloud provider and you want to collect something from S3, or you want to collect something from CloudWatch, there's a variety of receivers that you can use. There are different processors which helps you enrich the data, helps you filter and batch the data. And at the end, you have exporters where you can export your telemetry to different backends.
Now, some of you who might have probably looked at OTel, or if we look at the general industry trend, right, which happens whenever there's a new technology at play, there are certain limitations that people point out. And it could be because of the fact that they haven't been able to understand the technology correctly, or because, of course, the technology is still evolving. So what we did was we looked at some of the most commonly asked questions or the issues that people have pointed towards OpenTelemetry adoption. Some of them might say that it's very complex. The SDKs are not in the same level, so some of the SDKs have more parity, and that leads to reduction in the usage because companies are using different types of backend systems. Or sometimes, why do we even need to use OpenTelemetry when one could just simply use the combination of Prometheus and Grafana? Well, for certain use cases, that might be true, but I believe that, as I covered earlier, that the capability provided by OpenTelemetry with having built-in support for being able to look at all the different kinds of melt framework, metrics, logs, right? And also being able to understand what are the relationships between them under one single tool is what is the unique part of OpenTelemetry that sets it apart as compared to using a large number of different toolings. And what we've seen is that a lot of the improvements, especially in the last 4 years, have come into play with feature parity being improved across different SDKs, such that most of the common functionalities that you'll provide in OTel are common across different SDKs. And as Shivanshu mentioned about the semantic conventions, that goes a long way into making it and ensuring that the different terminologies that are at play with OpenTelemetry can easily be exposed and understood by people who are integrating OTel across different language stacks. And this ensures that the adoption rate of OpenTelemetry has skyrocketed. And not just for people building these applications, but I think ultimately, when we talk about the CNCF as a whole, right, we know that there are a bunch of different tools and different projects that are at play, and companies are increasingly adopting a lot of these different tools. So while we are building all of these large-scale applications with these tools, it's also important to ensure that they have native support for OpenTelemetry. And the good news is that most of the graduated projects or the biggest projects that we have today, whether it's with Kubernetes, with the kubelets, which have ingrained capability to export your logs and metrics because they have defined support for OpenTelemetry right inside of the kubelet API. So you can enable it and export all of your logs directly. Or if you look at some of the biggest projects that are there currently in the ecosystem, like Istio, Open Policy Agent, Envoy, Dapper, all of them either have native inbuilt support for OpenTelemetry or they have integrations with the SDKs. So it makes it very easy for you to be able to get details or logs. So for example, with as we'll explore with some inbuilt demos as well that we have in play for you today, you'll understand how each of these projects are integrating OpenTelemetry. So let's start by Dapper. So of course, Dapper with the sidecars, you can use this for more complex applications where you are having probably a lot of service meshes. It also has inbuilt support for OpenTelemetry by being able to send all of your tracing data through an OTel OLTP connection endpoint. And this makes it very simple to use, because if you're running some Dapper-based workflows, you can directly emit all of that tracing data inside of your OTel collector. Then, of course, if you're using a lot of policy-based agents, Open Policy Agent is one of the biggest tools that you will use. So with OpenTelemetry, you can actually emit all of your span-based data with the help of the OpenTelemetry collector, with the help of gRPC. And now I'll let Shivanshu cover Istio and Envoy with the demo.
So now, if you are instrumenting your applications, you are probably comfortable in sending the telemetry and configuring your SDKs or instrumentation agent to send the data to OpenTelemetry collector. But it can become quite complex if you want to configure it for any of the CNCF tools. Because, so for example, Kubernetes natively supports sending telemetry from kubelet to OpenTelemetry, but configuring that and upgrading the Kubernetes cluster might be complex. So let's take an example of Istio and see how we can actually configure it to send telemetry to OpenTelemetry collector. So let's get started with the demo itself. So let me just show you what we have as of now. So I have a Istio cluster up and running where I have configured a demo application in Istio demo namespace, and I have observability set up on this OpenTelemetry collector. So the way it works in Istio is you can have Istio operator configured to send OpenTelemetry to enable mesh config to enable OpenTelemetry, and it configures all the envoy proxies, and it sends all the tracing data, metrics, and envoy access log directly from the proxy to the collector. So let's see how it looks like. So here's my Kiali dashboard, and as you can see, all the traffic. I'm sending some dummy traffic from a simple curl request, and here this is how it looks like in the network flow. And if I go and take a look at my collector, so we can see that there's different spans coming from my gateway, from my ratings application, from my reviews application. And once you send this telemetry, collected telemetry to any of the compatible OTLP compatible backend, you can then see it in action. So for example, here I'm collecting all the traces and sending it to a SigNoz, which is an OpenTelemetry compatible backend. And if I go and search for, let's say, in the service map, I can see, just like Kiali, all the, let me go back and see, maybe it's not there. So in the traces, I can just search for my service name. Let me just try to refresh it.
So through this demonstration, what we are trying to also show is how you can very easily visualize all of those data that you have collected via the OLTP connector and use a backend system like SigNoz, where you can now very easily look at all of those traces data for particular services, or look at the complex network of your traces, metrics, all under a unified dashboard. And one of the other goals over here is to also show you that, but at least with this example, we showed how we are leveraging Istio, which is one of the most popular CNCF tools. But the idea is that you can replicate this across different types of other CNCF tools as well, who have offered native support for these particular systems.
Now, with minimal configuration in the Istio, all I have to do is just enable the telemetry API in the Istio control plane and in the Istio operator. And then I can have, like, without any instrumentation, because Istio supports natively OpenTelemetry, all the traces coming from the envoy proxies. And then I can just see the request flow. So here I can see that my book info application calls my product page, and so on and so forth. And one thing which is which makes OpenTelemetry unique is the attributes here have they follow semantic conventions. So if you are using different set of projects, they would have similar attributes which can help you correlate and do complex searches based on attributes. So here I can see, okay, what is my service name, what is my collector ID, and my upstream cluster name, my downstream cluster name, and so on. So this is how you can configure different CNCF projects to send all the data to OpenTelemetry. And it becomes very standard way to do correlations among different telemetry signals. In the same sense, we can use, if you are using Envoy or Envoy gateway in your networking infrastructure, you can configure the native Envoy telemetry API to enable Envoy access logs, and that also supports OpenTelemetry.
Yeah, so as we are kind of moving towards the end of the presentation, the first few minutes we wanted to kind of give you a bigger complex understanding of what OpenTelemetry is all about. And what we have understood is that it is the de facto standard that we are really looking at. And in fact, if you look at the popularity of the number of talks at KubeCons, or a lot of companies are coming into the observability space, right? Because as we know that having reliable uptime is the most important for any production use case. And that's why OpenTelemetry is seeing so wide usage. So when it comes to now adopting it at your workspace or educating more people around OpenTelemetry, what are some of the community efforts that are at play? So right now, there are 2 official courses and certifications that you can sign up for. So there is the official OpenTelemetry Certified Associate certification by the Cloud Native Computing Foundation. So you can sign up for it and you can get certified. And there's also a free 10-hour course right now that's available thanks to Linux Foundation, which is the LFS 148 course, which goes a bit deeper into what is OpenTelemetry. But at the same time, I think one of the key aspects of trying to understand the difference between any other technology and OpenTelemetry is that OpenTelemetry is really just focused on end use cases, right? So we want to basically showcase to the world or to everyone who is adopting OpenTelemetry that A, what's the importance, and B, how they can actually adopt it for their use case. So of course, by talking about the different CNCF projects, we want to show the active adoption of OpenTelemetry. But it doesn't just stop there. It's also how we can create more courses which are focused towards the adoption of OpenTelemetry for different industry use cases. For example, it could be collecting OpenTelemetry with your database, or it could be for the fintech industry. And that is where people will find more value and see how OpenTelemetry is a much better or a far better solution as compared to using 10 different type of monitoring solutions. So here's like a course outline that you can probably see from the coursework that I just showcased from the Linux Foundation, where it goes on and talks about OpenTelemetry in action and having dedicated labs on different things such as the traces, metrics, and logs. But at the same time, what I propose through this particular Cloud Native University is that more and more people should build different kinds of courses around OpenTelemetry in production and showing different kinds of use cases that showcase the value of OTel. So one such example is Spin, which is an WebAssembly-based project that is currently sandboxed within the CNCF. So they launched a cloud-native webinar on how you can integrate OTel with Spin project, which allows you to look at the metrics of the host function within your WebAssembly module. Another example is of like databases that have native support for OpenTelemetry. So in this case, this is an example of Couchbase, which is also part of the CNCF as the collector, so you can directly run that particular database and many other databases as well on Kubernetes itself. And there is native support for being able to send traces or your spans details via the different endpoints that are natively supported with the Java SDK for that matter. And there are also a lot of community resources that are out there today. So there is a very nice course on Free Code Camp on the YouTube channel. And there's also a really great playlist that I'll recommend to everyone, which is the Is It Observable playlist that goes above and beyond and talks about the best practices for OpenTelemetry in production. Finally, these are some of the other resources that we have covered today, including things related to Envoy proxy and Istio, which show the usage of OpenTelemetry in production in these systems. But yeah, with that, we will now conclude our talk. But as we have kind of demonstrated today, because we are at Cloud Native University, so the goal over here for us was to not only talk about what OpenTelemetry is, but also provide all of you resources that can help you get started by introducing OTel in your own projects. And in case you are a contributor or a maintainer of a CNCF project that does not yet have OpenTelemetry support, so please do add that. I think Shivanshu can probably talk about the CNCF working group for OTel.
Yeah, so we have different language-specific groups, and there are different working groups focused on specific parts of it. So if you are interested in contributing to OpenTelemetry or you have specific issues, please join our Slack channel and just post your questions. With that,
if there are any questions, we'll be open. Thank you.
Yeah.